So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with two-way tables, and in this video we'll be focusing on reading information, or in other words, writing fractions, percentages and probabilities from the information given to you in a two-way table. Now it is common that when you have completed a two-way table with all its values and its totals that you will be asked a specific question about it. Now often these are in the form of writing fractions, percentages and ratios and the probability of a person or item being selected at random from a group or the whole population. So in other words, whole population is like the grand total. Now before we move forward, it's really important that you're able to write fractions, write percentages and write ratios, and obviously then go on to simplify them and understand the concept of probability. Now if you've got no idea on what those four things are, then I strongly recommend that you watch the videos that are covered on the channel before continuing with this video. Now, as mentioned in the first video, it is vital that you read the information and fully understand and interpret the question being asked. It is also important that in a two-way table that there is more than one total. So for example, this total here represents the total number of boys. And this total here represents the total number of girls. The colour has no reference at all to those two genders. And this 20, or this bottom corner, the right corner, will always be the grand total. This number here, which this colour here, which is an orange, we'll go for is the total number that do not own a pet, and finally that let's go for this one, and this number here is the total number of people that do own a pet. So as you can see that there are 5 different totals. So when you're reading a question, if a question asks you what's the total number that own a pet, the answer therefore would be 13. If a question asked you how many out of all the girls, how many own a pet, well that would be 4 out of a total of 9 girls. So it's really important that you establish and understand what each of the totals in your two-way table actually represent. So let's have a look at this first example. So it says that Keith does a survey at his school. All the pupils take part in the survey and he draws his two-way table. And the first part of the question is saying, what 2 questions do you think he asked? So looking at this table, which the totals haven't been completed, we can see that generally the question is going to be, well, one of them is going to be, I'm guessing, what is your gender? Which in current climates you may have to have more options than that. What is your gender? And the second question could be, obviously it's going to be, what hand do you write with? Or it could be anything. But I'm just going to go for write with as 2 possible questions. It could be what hand do you hold your fork with, anything like that. So anything of use in terms of use of hands would be good for a second option. Now for part B, it then says how many pupils are there in the school? Now looking at the next couple of questions, like part C then says how many pupils in the school left-handed and how many boys are there in the schools, kind of gives me the impression that I'm going to have to work out the totals for each of these columns and rows. So let's just go about doing just that. So if we work out the total number of girls, that's 188 plus 32, which gives me 220. And we've got 203 plus 37, which equals 240. And that's going to give me an overall total of 460 students in total. So I can there have answered how many students are there at the school. It's going to be 460. Then obviously if I then go on to work out the rest, so 188 plus 203 gives me 391, and 32 plus 37 gives me 60. So looking at question C, it says how many pupils in the school are left-handed? Well, that's going to be 69. For part D, it says how many boys are in the school. Well, that's going to be 240. So let's just use a different color there. So that's going to be 240. And the next question, E, then says what percentage of the school. So of the school, that there is my total. And I then need to work out of the school how many are right-handed. So looking at E, it's going to be, well, how many are in the school? That's 460. And how many are right-handed? Well, that's going to be 391. So what I want to do is I want to convert this into a percentage. Now, if it was writing as a fraction, then I would simply just go on and simplify that as a fraction, which it does. So that would be 17. So as a fraction, this would be 17 over 20. But as it's asked me as a percentage, what I need to do is multiply that by 100. So whether I use 17 over 20 or 391 over 460, it doesn't really matter. And I should get 85%. So the answer to part E is going to be 85%. But again, if the question did ask me as a fraction, then I would have to write it as 17 over 20 in its simplified form, but the actual fraction would be 391 over 460. Now part F then says the percentage of girls that is left-handed. Now this one is slightly worded differently. So here my total is the number of girls. So the number of girls there are is 220. So it's going to be, for part F, it's going to be 220. And out of all the girls, how many are left-handed? Well, that's going to be 32. So if I wanted that as a fraction, I would do 32 over 220 and I'd simplify that, and that would give me as a fraction would be 8 over 55. But because it wants me as a percentage, I just multiply either of those two fractions by 100 and I get an answer of 14.54 recurring. So that's going to be rounded up, is going to be 14.5%. So writing my answer for part F is going to be 14.5%, and that's to one decimal place. Now, if you have rounded, it's always important that you state what you rounded it to. Ultimately, if your rounding is not great, you can always just copy the answer on your calculator or use the reoccurring symbols as we've got here. But again, don't forget the percentage sign like I almost did. So in this particular question, it involved percentages, didn't involve fractions, but you can see how I need the fractions to work out the percentage. But it's important that you don't just always, because you see the 460, don't automatically think that that's always the total that you use. Obviously, in some cases, when it's talking about the whole population or all of them, then it is. But again, with questions like part F, it might ask for a specific total, in which it might be different for the one that's in the bottom right-hand corner. So let's have a look at this second question, and we'll start by writing number 2. So in this question, it says that a survey is conducted in a town centre. The two-way table shows the results, and the question is asking what 2 questions do you think may have been asked. So I'm going to go on a limb and say for part A, I'm going to say what age group are you in? Is my first question, and what is your musical preference between pop and classical? Now I probably would have to go through the actual categories in terms of out of those 2 because there is no other. So if you're fans of rap, then unfortunately you've got nothing to highlight, and there's no option for you to that. So we'll have to properly specify in the question, okay, which is out of these 2 categories, genres, which do you prefer, pop or classical? So looking at question B, it says how many people took part in the survey. Now I'm going to be a little bit forward thinking and just work out the totals for every single column and row. So here I've got 64 plus 48 is 112. I've got 84 plus 14, which is 98. Then the grand total is going to be those 2 numbers added together, which gives me 210. And then 48 plus 14 gives me 62. And 64 plus 84 gives me 148. So looking at question B, it says how many people took part in the survey? Well, that's going to be 210. Do I need to show any working out? No. Well, if I've completed the table, there you go. But always have a look at how many marks it's worth. If it's worth 2 marks, then you might get it may get the 2 marks from completing the table or adding totals like I've done here, or you might show some work up. But generally speaking, I'll say 1 mark, and if you ever get the right answer, you probably get full marks on however many marks that's worth. So part C then says how many people in the survey were 30 and over. Well, 30 and over there is going to be 112. Then part D then says how many people in the survey preferred classical music. Well, that's going to be that total there, so that's going to be 62. Now part E then starts now introducing ratios. Now in ratios, it's asking me for pop to classic. So that's the ratios that I want to be writing. So for part E, now in this one, I'm just looking at the over 30s. So the over 30s, which is this group, this column here. So that's going to be, for part A, it's going to be pop to classic, and that's going to be 64 to 48. Now, just like with fractions, you always want to be simplifying your ratios, and that's going to simplify to be 4 to 3. Then with part 2, here we're looking for another total. So this is the total of under 30s. So that's this column here. So that's going to be pop to classic is going to be 84 to 14. And again, I'm going to go on to simplify that, which would give me is going to be 6 to 1. And for part 3, it's saying in the survey, so that's going to be the grand total out of 210. So that's going to be pop to classic is going to be 148 to 62. And again, I'm going to simplify that, which it does, to give me 74 over 31. And there is my final answer. So that's given me in terms of ratio. So whenever you're dealing with ratios, always make sure you're looking at the right column or row, and you're obviously just going for those numbers in that. So I didn't actually need to know the totals for that, but obviously I did need to know which column and row I'm looking at. Then for part F, it says what percentage of under 30s. So the under 30s, so I'm looking at this column here. And let's get so for part F, I'm looking at what percentage of under 30s preferred pop. Well, how many under 30s are there? Well, there's 98. And out of those 98, how many people chose pop? That's going to be 84. So if I wanted it as a fraction, that is my answer in terms of a fraction. And simplifying that would give me 6 out of 7. So that would be the full mark answer. But because I want it as a percentage, I just need to multiply that by 100. So if I multiply that by 100, I get 0.857. If I don't, I get 85.7. 7142857, blah blah blah. So all I then need to do is round this percentage up. So I'll round up to 1 decimal place, and that's to 1 dp. There is my final answer. So again, if the question did ask me for what fraction of under 30s preferred pop, then I would have to give 6 over 7 or 84 over 98 in its unsimplified version, but 6 over 7 would be the full mark answer. So moving on to our third example, so let's just write number 3 there. So it says, in a biology project, data is collected on pupils and parents to see whether they can roll their tongue. The data is shown in the table below. So here we've got our table, and you can see notably that we've got no totals. So let's go on to just write down those totals. And guess, because although nothing has told me that I need to work out those totals, but I'm going to go on a limb and say that I'm actually going to need to know them. So this one here is going to be 104. So the next one is 54 plus 28, which is 82. And I've got 14. And then adding all of those numbers up, I get 200. And then adding up the first row, I get 94 plus 54 equals 148. And 10 plus 28 plus 14 gives me 52. And let's just stick some separators in that to make it a little bit more obvious. Right, so part A then says how many pupils can roll their tongues. So here we just got to pick out the right bit of information. So it says how many pupils can roll their tongues. Well, that's going to be 148. Now the next question then says, what ratio of pupils can roll their tongues to those that cannot? So this, I'm going to be going for this number against this number. So it's going to be that can to can't, and that's going to be 148 to 52. Now again, just like with fractions, we want to simplify that. So I've got 148 to 52, and that simplifies to give me 37 to 13. And there's my final answer for that one. Now for part C, it then says one pupil is chosen at random. What is the probability that he or she can roll his or her tongue? Now here we just got to make sure we're looking at the right total. So now here it says one pupil is chosen at random. There's no specific sort of grouping of that, so that's going to be the whole entire total. So for this one, again, it's going to be quite difficult for me to down, so let me just put C. So it's going to be over 200, and so how many can roll their tongue? Well, that's going to be 148. And again, what I then want to do is simplify that. So what number goes into both, and just basically simplifying that, and I get 37 over 50. Divide both numbers by 4. Now part D then says that if both parents can roll their tongues, so if both parents, so we're looking at this column here, so if both parents can roll their tongue, what is the probability that their child cannot roll his or her tongue? So again, we're going to make sure we're going for the right total, which in this case is 104. Now out of those 104, how many cannot roll their tongue? Well, that's going to be 10. So then all we then need to do is simplify this fraction. So that's going to be 10 over 104, and that's going to give me 5 over 52. Now what is important is that when it comes to probability, particularly at Key Stage 3 or GCSE, that you want to make sure you're giving your percentage as either a fraction or a decimal. Now personally, I would always opt for the fraction version because it's always accurate, but if you were to give your answer in terms of a decimal or even as a percentage, that you should be, as long as the value is correct. So for this, the decimal version would be 0.096153, and it carries on, or that would be 9.6% to one decimal place. So as long as you're using the correct form of rounding and the correct value, you should get marks whether you use decimal, percentage or a fraction. But again, a word of advice when dealing with probability, try and keep to fractions, or the next one is going to be a decimal. Now for part E, it then says that a pupil who can roll their tongue is chosen at random. So if I just get rid of that highlighting that's in the table, so get rid of this yellow. So it says here we're looking at the group that can roll their tongue. So the group that can roll their tongue is, and let's just get rid of 2. Add that 8. So I'm looking at this group here. So pupils that can roll their tongue. So I'm looking at these 148 students. And it says, what is the probability that only one of their parents can roll their tongue? So here it's looking at 54 out of 148. Now again, as I'm writing it as a fraction, I want to make sure that I simplify that, and that does simplify to give me 27 over 74. Now if I wanted to give that as a decimal, then it would be 0.364864 or 0.4 to one decimal place. Or if I wanted to write it as a percentage, it would be 36.5% to one decimal place. But again, try and leave it as a fraction. Now for part F, it then says that if neither parent can roll their tongue, so let me just get rid of all of this shading and that. So we're looking at if neither parent, so what we're looking at is this column here. So the question then says neither parent can roll their tongue. What is the probability that their child will be able to roll their tongue? So looking at this, I'm looking at out of 14. And how many of those 14 can roll their tongue? Well, that's going to be 0. So 0 over 14, which is basically 0. So if neither of your parents can roll their tongue, chances are you ain't got a chance to, or according to this biology project, there is 0 chance of you also being able to roll their tongue. So like I said, I will put some practice questions in the description below for you to practice this use of two-way tables. But like I said, these types of questions tend to come more popular on higher questions or delving into that knowledge of two-way tables. So once you've mastered how to complete a two-way table, the next thing is being able to answer questions. And typically it's about working with the totals, working with fractions, working with percentages, and eventually moving on to probability.